Hey everyone, welcome to this explainer. I am absolutely pumped to have you here today. We are going to unpack the story of the ultimate, epic survivor of our natural world, and that is water. I mean, it's something we interact with every single day, right? But when we actually stop and look closer, the chemistry and the incredible journey behind a single drop of water are truly extraordinary.
Okay, let's just dive right in. You probably know the fundamental fact that water covers roughly 71% of our Earth's surface. But I really want to frame this with a completely mind-bending reality. Because of the way our planet perfectly recycles matter, the exact same water you poured into your glass today is literally the exact same water that dinosaurs drank millions of years ago. No way, right? But it's true. It hasn't left the planet. It's just been continuously moving and transforming this whole time. To understand how that's even possible, let's look at our roadmap for today. We're going to hit 6 key areas: the ultimate survivor, the chemistry of pure water, nature's perfect recycling system, the pollution threat, the science of water treatment, and finally, protecting our water future.
Let's start with Section 1, the ultimate survivor, and take a look at exactly why water matters so much in Uganda and beyond. Moving right along to Section 2, the chemistry of pure water. We're going to strip water all the way down to its microscopic molecules. So, what actually is water? In our everyday lives, we toss the word pure around pretty loosely, don't we? But scientifically speaking, pure water is a very specific chemical compound. It's made strictly of just 2 elements, hydrogen and oxygen. Yep, that famous H2O. When a chemist says pure water, they mean it contains absolutely nothing else. 0 dissolved minerals, 0 salts, 0 impurities. Just those specific molecules, and nothing more.
Now here is a massive misconception. If you pump some crystal clear, sparkling water out of a village borehole, you'd probably assume it's pure, right? Actually, scratch that. It's not. Clear water is heavily filtered by the earth, for sure, but as it sits underground, it dissolves these invisible salts and minerals from the surrounding rocks. And here's the funny thing about that. Those dissolved minerals are exactly what make borehole or spring water taste so good. True, 100% pure water usually has to be created in a lab, and honestly, if you drank it, it tastes completely flat.
So what are the baseline stats of this pure water? Physically, it literally sets the standard. It freezes at exactly 0 degrees Celsius and boils at exactly 100. It's also known as an incredible universal solvent, which just means it dissolves other substances super easily. And chemically? Well, it's perfectly neutral. It's not an acid, it's not an alkali. But hey, don't mistake neutral for boring. It reacts fiercely with active metals like sodium, and it's the absolutely vital medium that allows everyday chemical reactions, like the rusting of iron, to even take place.
All right, Section 3. Nature's perfect recycling system. This is all about how the Earth actually cleans its own water.
You see, nature has designed this epic, never-ending recycling loop to ensure we technically never run out of water. And the whole shebang is entirely driven by the heat from the sun. We call it the water cycle. First off, the sun's heat causes evaporation, turning liquid water from our lakes and rivers into invisible water vapor. But plants get in on the action too through transpiration, which is essentially them breathing out water vapor right from their leaves. As all that vapor rises up, the colder temperatures high in the sky cause condensation, turning the gas back into tiny liquid droplets to form clouds. When those clouds get way too heavy, boom, we get precipitation, rain, hail, or snow falling back down. If you're in central Uganda, you'll definitely recognize this during the heavy rainy seasons of Togo and Dumbi. Finally, that water becomes surface runoff or soaks deep into the ground, completely ready to start the cycle all over again.
And you know, this brilliantly illustrates another incredibly important chemical concept. When water evaporates up into the sky, it doesn't take the dirt and the salt with it. Evaporation acts exactly like nature's own distillation process. Only the pure water turns into gas. All the pollutants, the heavy metals, the dirt, they are left grounded. So the water floating around in those clouds is naturally purified.
Which brings us to Section 4, the pollution threat. Basically, what happens when humans disrupt the cycle?
So if nature's recycling system is so perfect at cleaning water, what happens when human populations completely explode and massive industries expand? Well, unfortunately, we disrupt the cycle. And we are seeing severe threats to our water bodies right now. We've got industrial chemicals being pumped directly into lakes without any treatment. Untreated sewage is finding its way into rivers. When it rains, all those chemical fertilizers and pesticides used on farms, they get washed right into the water supply. And of course, there is the massive physical pollution from the dumping of plastics in Kivira. You know, those thin plastic bags that just completely choke up our waterways. We are actively poisoning our own well.
Now, nature isn't completely defenseless here. It does have a mechanism against the surface pollution, wetlands. You might have actually heard swamps, like the Lubiji wetland in Kampala, referred to as nature's kidneys. Because as dirty, polluted runoff water flows through a swamp, the dense plant life and soil act as these incredible biological filters. They trap heavy metals and dirt, literally cleaning the water before it ever reaches Lake Victoria. But as we drain these swamps for building projects, we are losing our natural kidneys.
Let's move to Section 5, the science of water treatment. Welcome to the Municipal Purification Gauntlet.
When our lakes become too heavily polluted and we just can't drink straight from the source anymore, we have to turn to chemistry. We use it to replicate and speed up nature's cleaning process. If you live in a city like Kampala, your tap water comes from the National Water and Sewerage Corporation, and they put every single drop of that dirty lake water through a rigorous scientific gauntlet. It starts with screening, using these huge metal grids to catch the big stuff like sticks and plastics. Then comes a totally critical chemistry phase, coagulation and sedimentation, where chemicals literally force dirt to settle. Next up is filtration, where water is forced through really thick layers of fine sand and gravel. And finally, chlorination, where specific chemicals are introduced to kill off all the dangerous, invisible bacteria.
Let's zoom in on that second step for a second, because honestly, it's arguably the most fascinating piece of chemistry in the whole plant. It's called coagulation or flocculation. You see, lake water is often full of microscopic mud particles that are so incredibly light, they just float indefinitely. The water would stay cloudy forever. So, chemists add a compound called alum. The alum chemically reacts with these tiny floating mud particles and literally forces them to stick together. They form these larger, heavier clumps called floc. Because they are now heavy, gravity takes over and the mud just drops right to the bottom of the settling tanks, leaving beautiful, clear water on top. It's absolutely brilliant. Okay, just to make sure you've really grasped this whole purification gauntlet, let's contrast the final two major steps. Filtration is a purely physical process. You are literally trapping tiny dirt particles by forcing the water through layers of sand, which is exactly what nature does when water seeps underground. Chlorination, however, is a chemical defense. That water might look perfectly clear after filtration, but it could still be teeming with deadly microbes that cause cholera or typhoid. Adding chlorine chemically destroys those invisible germs, making the water 100% safe to drink.
And finally, Section 6, protecting our water future. It's time to apply the science.
Look, the goal of learning all this isn't just to memorize facts. It's to apply this science to our real world and truly understand the urgent need to protect our environment. I want to leave you with a provocative thought based on everything we've talked about today. The entire water cycle is driven by the sun's heat, right? So if global temperatures continue to rise due to climate change, how exactly will that alter the delicate balance of evaporation and precipitation? What happens to the farmers waiting for the Tuchogo rains, or the hydro dams like Jinja that literally power our cities if the cycle breaks its rhythm? Water is the ultimate survivor, yes, but our access to it, that is entirely up to us. Think about that the next time you turn on the tap. Thank you so much for joining me for this explainer, and keep learning.